This video will reintroduce how to use Bootstrap Intervals to estimate an average from a population, and we'll also introduce how to use the same exact formula to determine an estimate for the true percentage or proportion from a population. So it's Mr. I again here leading you through, and with this first page, pause the video if you need to, if you do not have the materials in front of you, and if you know how to do these questions from our last video, give these questions a try, and then I'll go through the solution with you after you unpause. All right, so let's begin with looking at A, B, C, and D. So with this first question, for A, they're asking us to construct a t-interval using the techniques that were discussed earlier in the course, and it has three steps to it. First step is to check to see if it was a simple random sample. It's not. The sample size is not greater than or equal to 30, and after graphing the data, the original data, we can see that there's an outlier, and that's troublesome. We really don't want to have those outliers when our sample size is less than 30, but we press on. As with any confidence interval, we've already said our piece about how this interval is flawed to begin with, but we still continue onward and calculate the t-interval, and that can be done on a calculator menu, or it can be done by using the formula like I showed there. Remember, the degree of freedom is always one less than the sample size. So our degree of freedom is 14, and using a confidence interval of 95%, I was able to figure out using the table that the t-value was 2.145. So using that technique, we're finding that the method is actually indicating that the true average very likely could be between 42 and 98. 95% of the time, the method will find the true average. And it's a pretty wide interval, and a lot of that has to do with the fact that the sample size is so small. Okay, for question B, use the random integer command to create one bootstrap sample. So what I did was I pressed the math button on my calculator and chose random int, and asked the calculator to give me a random number between 1 and 15 and give me 15 of those. A bootstrap sample has the same size as the original sample. So when I pressed that, it told me that these were the movies that were in my sample. Then I went to the list and found out movie 2 had 60 swear words in it. Movie 14 had 50. Movie 1 had 15, and I recorded that sample. That's a bootstrap sample. And from that bootstrap sample, I added them all up and divided by 15 to figure out that my average from my bootstrap sample was around 58. So that's what the computer is actually doing when you visit the website, is it generates random bootstrap samples and calculates their averages and plots them. So you can see that the work that I'm about to show you will generate the two important numbers that you need in order to pull off calculating a bootstrap interval. So to the website we go. On this website, if you click Edit Data, you can clear out anything that might be there and replace it, as I have, with a title, the number of swear words, and typed in all 15 movies for how many swear words they had. Once that's done, it displays the original sample here, and jumping right into it, we can calculate one sample at a time. This average came out to be 76.6. We can do that again. Another bootstrap sample had an average of 68.1. Why settle for just creating one at a time we can generate thousands and thousands of these samples, and this should mimic the variation in the central as the central limit theorem would. So our standard error or standard deviation here will be roughly the same as what we would get if we took simple random samples from the original population instead of reusing these samples over and over again. So you can see I'm up to over 11,000 samples, Bootstrap samples. The average came out to be about 70, and the standard error or standard deviation came out to be about 12.6 or 13. I'll be very aggressive with the rounding here, and I'd use 70 and 13, and that's what we did in the last video. I'm willing to bypass question E in terms of how much different these are in calculating the percent error in comparing how the t interval compared to the bootstrap interval. But if we take a look at the t interval, it had a margin of error of 28, and I suppose, it's an improvement. Using the bootstrap interval, our margin of error got reduced to 25. One of the reasons why these margin of errors are coming out so large is because the sample size is small, and this technique is trying to do the best that it can and trying to hold up and maintain that level of being 95% correct. I believe there are other techniques out here, slightly different formulas that could actually give you a more precise answer, and you would use those if you were given a small sample, as we have here. But that'll be something that is taught in another course, not in this class. But moving on to the second page and introducing the confidence intervals that will help you determine the true percentage. We can use the same exact formula as we did on the first page to handle questions such as this. So let me frame it for you if you do not have the worksheet, so you can take a good look at what I'm about to lead you through. Take a screenshot of it if that helps you in terms of taking your notes. All right, and unlike the last one, I'm going to lead you through this live right now. So given the population of all students in the school, we take a simple random sample of 10 students. Their names are given below. Next to each student is not a number. It's not like how many times they swore per day. It's either a yes or a no, whether or not they own an iPhone. So just like we did with creating a Bootstrap sample involving data that was numeric, here we're going to create a Bootstrap sample of yeses and nos. So on my calculator, I would go to Math and choose the probability menu, PRB, and ask the calculator to give me a random sample of 10 students from the list of 10 students. And this would be my Bootstrap. This will help me figure out my Bootstrap sample. So I would type into the calculator, give me a random number between 1 and 10, and give me 10 of them. Well, I did that already on the next page, which could save me a little discussion. So when doing that, I end up getting student number 3, student number 6, student number 9, student number 8, student number 2, 8 again, student number 5, and so forth, student 3, another 8, and student number 1. So I found out which students would be in my Bootstrap sample, and then I figured out what percent in my sample own an iPhone. So looking at the list, any name that's underlined in red owns an iPhone. So in my sample, 6 out of the 10 students owned an iPhone. So my sample percentage from my Bootstrap sample was 60%. Now you could do that yourself, repeat questions 1 and 2 on your own. I did, and I got a different group of students. This time I got 30% of my sample having an iPhone. And we could keep on doing this over and over again. In question number 4, gather more sample proportions from by repeating this process or getting a group of people to actually help you do this. And I did that myself, and I created a Bootstrap interval using 22 of these Bootstrap samples. So I had a list of 22 numbers that I typed into the calculator. I wonder if it's still there. I believe it is. So stat edit. I think I hit it way over here, list. No, it's gone. Well, in any event, under list 1, 2, or 3, you can type in all of these Bootstrap sample averages, and the calculator using 1var stats can give you the average and the standard deviation from those samples. And that standard deviation is going to be called the standard error, because each of these samples, each of these data points represents a sample, and the standard error is slang for what is the typical distance from the average to your samples. So using the information from 1var stats, I could just type that into the same exact formula that we used for calculating the Bootstrap intervals for averages, and apply it to the percentages, get a margin of error of 24%, so somewhere between 16% to 64% of the students in the school own iPhones. Pretty wide margin of error, and again, a lot of that has to do with the fact that the sample size is so small. And I'm doing that mostly for convenience, but it could actually happen in real life if you had a sample size that was pretty minute, like 10 students. Drawing conclusions out from a group of 10 is bound to create a margin of error that's pretty large, but I'm doing it mostly to save time, considering we're typing in and writing all these results down. And the technique would be more successful with a larger group of students. And all right, so now actually moving on to question number 5 is that you can actually create the Bootstrap interval with a little more precision using more samples. So instead of using 22 samples, we could actually use 11,000 or more samples and get that average and percentage and get that standard error to be a little bit more precise. So let's actually show how that's done on the website. So it's not the same exact location as the previous one. It's on the Lock website, and it's the Bootstrap with proportions. And if you follow that link there, or if you're in my class on Schoology, there's a link for it, which brings you to the stat key confidence interval for proportion generator. You would go to edit data, and you'd begin with typing in not a list of yeses and nos, not a list of numbers, but just typing in that sample how many students owned iPhones. It was 4. And how large is the sample? It was 10 students. So it's that quick and easy to type in the results from the worksheet from the original sample. And now we're going to create Bootstrap samples from there. We could do it one at a time by clicking Generate One Sample. So this time, in the group that was selected, 5 of the 10 students had iPhones, so 50%. You could do that again one at a time. You could have a whole class do it, which would give you a sample size of 22, which is what I did. Or you could have an entire town create bootstrap intervals. And instead of calling each person on the phone or getting them on social media, you can just let the calculator simulate, or let the computer simulate, the generation of thousands and thousands of samples. And I guess generally once you get to the point where these numbers aren't changing much, then you know you've pretty much gotten an answer that's about as accurate as can be. So after a while, these numbers really don't budge very much. So it looks like we're at 0.4 and 0.155. And those are the two numbers you would use, the mean and the standard error in your formula. Convenient and nice, because we can actually use this bootstrap interval technique to create intervals for averages, for proportions, and even do some other things such as create confidence intervals for medians, and I believe even standard deviation, which is kind of unusual, but you can actually use this interval. It's like a Swiss Army knife. It could be used in a lot of different, it could have a lot of different applications. And one other thing is very interesting about, I think about this is something that was created in my lifetime. I believe I was in high school when the professors at a university came up with this idea, I believe. So this is something that's gaining popularity now because of the fact that we've got the computer to actually do this for us. And I'm sure back in the 1980s, the computers were quite large and still kind of on the new side, so they probably couldn't crunch the numbers as quick as we are here by just with a click of a button. We're getting 16,000 samples in probably 1 second. So it's impressive to me, and I guess it's gaining popularity for a lot of different reasons. Oops. So that would be the final answer there. So somewhere between 15% to 66% own iPhones, and the answer is very, very similar to the one that was above, as it turns out. Which is, I guess, quite interesting because this involved only 22 students, 22 bootstrap samples, and this included thousands and thousands. So this was a little bit off target because of the fact that there was only 22 samples, but yeah, I suppose one other thing worth mentioning is that the website does have some limitations. If you clicked on to tail, like we did for the averages, remember that pretty much gave us, for the averages, gave us a pretty good estimator on the interval from here to here. Looking back at the example, we were looking for a 90% interval. So if you wanted to use the website to do this, you can click on the 0.95 in the center and change it to 0.90. But the programmers who worked on this, for whatever reason, it could be because they know more than I do, or it could possibly just be the fact that there's limitations to the way that the website displays the answers, is that they rounded the answer to the nearest percent. So the confidence interval they're coming up with is between 20 and 70, when if you take a look at the one I generated with the formula, it's 15 to 66. So mine ends up being a little bit more narrow because there was no rounding involved. So and then in this case, it's actually much better because it's a more narrow interval. And yeah, so that's a little walkthrough of how to do this. And if you're in my class, of course, this is just a review because I've already given you this lesson, or will be giving you this lesson shortly. All right, well, that's it for our bootstraps. And next stop for us will be working on hypothesis testing. So you have a great day.